Good morning, everyone. I am Revati from the Department of Computer Science and Engineering in the Government College of Engineering, Singipati. Now I'm going to explain the concept of deadlock in DBMS. So basically, what is a deadlock means? Uh, Deadlock is a condition where two or more transactions are waiting indefinitely for one another to give up locks. So deadlock is said to be one of the most feared complications in DBMS, as no task ever get finished as and is in waiting state for. That is, the definition explains no one get execute the transaction and no one operations is completed. That is, the DBMS does the database updation, recovery, like that any transaction has been made at the system, that is called transaction. That is one for example, the T1 is a transaction transaction that accesses a student database, and T2 is another transaction that accesses a database grade. So here the T2 transaction requests the student and T1 transaction requests the grade. But after completion of T2 only, this database will be accessed by the T1. The same way, after completion of T1 only, the student will be provided to the T2. So now T1 is waiting for T2 and T2 is waiting for T1. So like that, the transactions are waiting for one another and no one can complete their transaction immediately. So then all the transactions are in the waiting condition. So this is not a fair condition in DBMS execution. So here, for example, this is one type of example is traffic jam. So for example, we are seeing this traffic jam. There is a two buses in between the traffic and between the road. So first these two go that side or this side, otherwise this road will not be clear. So here this bus is also cannot go there because here also some traffic and here also some. So all the cars and all the buses will be waiting infinitely because no one can move any way. So that is this condition is made in the database, that is called deadlock. So here there is a condition, the process 1 that is locked by the resource 1 and resource 2 is locked by process 1, and again it requests the next resource 3. So now resource 3 is also granted by actually this is granted by process 2. So process 2 already accessing request 3, but the process 1 is also requesting this resource 3. So now here these two this process 1 completed after getting the resource 3 database, then only we can complete the transaction. Now the process 2 is also accessing the resource 3. So here it creates a deadlock, and the same way the process 1 accessing a resource 1 and it also send the request to the next other resource. So here this is requesting for, this is accessed by another process. Like that continuously the resources request is allocated for one another, and that is requested by another one. Like that it is waiting. So like a chain connection, the resources and processes are waiting. This is called deadlock. So in this condition there is no action can be made, so that we have to avoid this situation. So in this situation there is no transaction, and we are also waiting for a more time, other process is also waiting for that resources, so no action can be made at that system. So this is a bad situation, so that we have to detect where the deadlock is happened. The resource scheduler can detect a deadlock as it keep track all the resources that are allocated to different processes. After a deadlock is detected, it can be resolved using the following methods. So that is, once the deadlock is detected means we have to follow where the deadlock is happened. And so we have to detect, if you want to detect means there is a two approach. One is we have to pre-emit, and otherwise you have to terminate. So so first approach is all the processor involved in the deadlock are terminated. So terminated means again it restart the process, and again it send the request to access the process. So here this is not a fair condition, so because the waste of time, again it going to execute the same transaction again, so the processes are destroyed. So this is a first approach. And second approach is resources can be pre-emitted from some processes and given to others till the deadlock is resolved. That is, one resources only given to other process, and after completion of that we are allocating to other process. Like that we are sharing that resources to anyone. That is, preempting means we are getting the resource and allocate to some process. If once one process is completed means other process will easily completed. So like that we can reduce the waiting time. So this is a two deadlock reduction method. And next, the better way is a deadlock prevention. So mostly our transaction cannot enter into a deadlock, so like that we have to write a program. So otherwise we have to write a share the resources. That is a deadlock prevention. So it is imperative to prevent the deadlock before it can occur. That is a good condition. So the system rigorously checks each transaction before it is executed to make sure it does not lead a deadlock. If there is even a chance that a transaction may lead to a deadlock, it is never allowed to execute. That is, it never allowed to execute if any one transaction create a deadlock. For that we have to take other actions. So there are two deadlock prevention condition. One is wait die scheme, and another one is wound wait scheme. So this is done by, these two schemes are done by a timestamp method. So these two deadlock prevention scheme that uses a timestamp in order to make a deadlock prevention. So first method is a wait die scheme. So what is a wait die scheme means, if a transaction T1 requests a resource that is held by transaction T2, one of the following two possibilities, that is T1 and T2 are two transaction is in the database operations. So first, TS of T1, timestamp of T1 is less than timestamp of T1. There are two conditions, less than T1 less than T2 and T1 greater than T2. So there are two conditions. First condition, T1 is less than T2 means if T1 is older, T1 come in the system earlier than T2. So before T2, the T1 has come to the system to access a resource means it is allowed to wait and for the resources which will be free when the T2 completed it. That is, it goes to a wait condition because you are coming the system very earlier, so you just wait for some time. After completion of T2 only, I have to give the permission to execute the resources. That is first condition. Second one, if T1 is greater than T2 means, that is T1 is younger than T2. The T1 is enter into the system after T2 enter means the T1 is killed. That is, you cannot come into the system now because it creates a deadlock. So I have to kill your transaction. You have to restart the timestamp. Like that, I have to destroy the T1 condition because it is entered into the system after T2. So for that, so if it is before means I have to put into the wait condition. If it is after the T2 means I have to destroy the condition, or it is killed by the resources. Okay, so this other this scheme is called wait and die condition scheme. Next one is would wound and wait scheme. So in the scheme, wound wait scheme is a T1 the same way. There are two transaction T1 and T2. T1 request a resource that is held by transaction T2. One of the following two possibilities. The same way, T1 is less than T2 and T1 is greater than T2. So there are two conditions. So here T1 is older than T2. That is, T1 after come into the system earlier means then it is allowed to roll back T2 and wound to T2. That is, T1 takes the resource and completes its execution. T2 is later restart with the same timestamp. That is, I'm come earlier, but now the T2 is accessed by the resources, so I have to wound. Now my resources are given to the T1 and complete its execution. After execution of T1 only, I go for a T2. Say next one is T1 is greater than T2 means T1 is younger than T2. So T1 come in the system after the T2, it is allowed to wait. So wait for some time. After completion of T2, I will give the permission to access the resources. It has been executed. So there are two conditions. Here it wounded. Wound means we have to give the permission first execute the T1. That is because T1 is earlier, and here T1 is later come into the system. So I have to give wait and after execution of T2 only you have to execute the resources. So there are two schemes used for deadlock prevention. Next one is deadlock avoidance. So how we avoid the deadlock? So before coming to the system, we have to allocate the transactions resources with the don't enter the deadlock condition. Like that, we have to write a program that is called deadlock avoidance. So the better way to avoid a deadlock rather than make measure after the deadlock has occurred, the wait for graph can be used for a deadlock avoidance. Once we have to make a relationship between the transaction and resources, then we can get one idea how the resources are allocated and how the transactions are executed on the database. Like that, we can make one graph. So that graph tells if it makes a cycle or it does not make a cycle. If it is make a cycle means the resources must execute a deadlock. So we have to write a program. We have to write a transaction and allocation of resources without creating a cycle. So if the graph does not creating a cycle means that will never gets the deadlock condition. So for that, we are using a wait for graph. The wait for graph shows the relationship between the resources and the transaction. If a transaction requires a resource or if it is already hold the resource, it is visible on the edge. That is, already hold means we are executed in the term of edge on the wait for graph. If the wait for graph contains a cycle, there may be a deadlock in the system, otherwise not. So if the graph creates a cycle means it can oftenly create a deadlock. Next one is so this is a wait for graph definition. So the deadlock can be described as a wait for graph which consists of G is a graph equal to V comma E. V is a set of vertices and E is a set of edges. So what is Ti tends to Tj means here this is a edge Ti to Tj E. This is a edge E. Then there is a directed graph from the Ti to Tj implying that Ti is waiting for Tj. That is, Ti is waiting for Tj's resources to release that data item. The system is in the deadlock state if and only if wait for graph has a cycle. So the wait for graph creating a cycle means that having a deadlock. So this transaction must create a deadlock. So we have to avoid that transaction. Then we have to make the changes in the edges. Then we can easily avoid the deadlock. So must invoke the deadlock detection algorithm periodically to look the cycles. So periodically we have to check the wait for graph. Then we can easily avoid the deadlock. So this is an example for wait for graph. So this here T1 is accessed for T1 is waiting for T2 and T2 is waiting for T3, and here T4 is waited for T3. So this will not create a deadlock, but here this will create a deadlock because T1 is waiting for T2 and T2 is waiting for T3 and T3 is waiting for T3 is waiting for T4. So here T1 execute the transaction, it release the T2, it release to T2, and T2 is executed, the database T4 transaction is also executed, and T1 transaction is also executed. So both if T2 is execute the transaction means the T1 and T4 can be executed. Here T1 is waiting for T2, T2 is waiting for T3, and here T4 is waiting for T2 is free, then only T4 is executed, and T3 if you want to execute a T3 means here the T4 is also free. So this will create a cycle. So this graph must create a deadlock. So we have to avoid, we want to avoid means here this edge cannot be executed. So if you are free this edge means the cycle will be does not create a deadlock. Like that we have to arrange it. Next one is recovery from the deadlock. So how we are, once we have made a deadlock means how we are made the recovery for the transactions database. So the common solution for is rollback. So only one common solution is rollback. We are going for a before consistent state. That is what is a before state, that is a redo state. Like that we going for a before transaction state, or more transaction to break to the deadlock. So there are three actions to be made. One is selection of victim, second one is rollback, and another one is starvation. So what is a selection of victim means set of deadlocked transaction must determine which transaction to roll back to break the deadlock. So there is only one transaction that create a deadlock, so I have to break one transaction, and otherwise I have to roll back only one transaction, and the deadlock can be easily. So we have to make the transaction, only one transaction have to roll back, and all the transaction will be executed successfully without a deadlock. So like that we have to select one transaction for rollback, that is a selection of victim. So consider the factor. So this is for minimum cost. So if you are accessing more than one transaction to roll back means it create a more cost, and all the transaction must execute again the transaction again a transaction is execute the database. So here we made a one transaction to execute the rollback. So that is a selection of victim. Next one is rollback. Once we decided that particular transaction must be rollback means must determine how for this transaction should be rollback. So how we are rollback, that is one before what is a before consistent state, from that we have to execute the transaction, that is a rollback. And next there are two next one is total rollback and partial rollback. That is partially committed means partial committed committed transactions is continued, and total rollback means totally all the transactions are aborted and it takes a condition. And next it access resources, and then starvation. So this is a situation ensure that transaction can be picked as victim only finite number of times. That is starvation means we are getting one transaction to roll back for break up the transaction, break up the deadlock. For that the transaction cannot be rolled back to more number of times. For example 100 times if you are roll back the same transaction means it creates a time, maximum of cost, and consistent status rollback. So this is not a fair condition. So for that we have to get the transaction roll back with the minimum number of times, not a maximum number of time. It cannot be in the infinite number of time we are getting roll back the transaction means this is also creating a deadlock. So the starvation means there is a condition, this transaction must be rolled back with a finite number of times only. So this is a deadlock. What is the deadlock? Deadlock prevention, deadlock avoidance, and recovery of deadlock. Okay, thank you.